So next up, we have John Curran, who's the president and CEO of ARIN, has been involved with ARIN since its very inception, and he's going to tell us about IPv4 exhaustion here in our region, and specifically at ARIN. Yep, thanks, John. I think you should reset to...
It's all good. I actually never liked following Jeff Houston because he's an entertaining speaker and he's always insightful. It does seem a little relieved to follow him when he's electronic, though. And so hopefully I will be equally as entertaining and as exciting as Jeff is. A lot of you have seen this. There's nothing new, but I want to put us all on the same page for the discussions that will take place today. So let's see. What do we know? History of the Internet Protocol. IPv4, 32 bits, 4.3 billion addresses. It's what the Internet built its success upon. It's been standardized since 1978, and it's allocated based on need. There was a central pool, and as organizations needed it, they asked and got address space issued. IPv6, as Jeff said, Frank Katzenholz and Frank Solinsky put together some forecasts in 1990 at the Address Limitation Working Group, the ALE working group of the IETF. And I was part of that working group, and it was very scary looking at slides that said we were going to run out between 2010 and 2017, which was what the range of estimates were. That led to the IPNG working group, led to 6 or 7 proposals, all of which competed with one another. A very exciting time. We had the typical things that happen in competitions where you had some of the competitors merge teams. There was fratricide as one proposal killed another. It was a good time. There's a wonderful set of stories there to be read by people. But the fact is, at the end of the day, we came up with a new IPNG protocol. And the new IPNG protocol, what we now call IPv6, is supposed to be a simple extension of what we did with IPv4, only with 128-bit addresses. There are some other improvements. We all know that. We've talked about them at length, but there are things like built-in security, things that we were working on as enhancements to IPv4 became part of the IPv6 spec. The fact of the matter is that the main important point is 128-bit addresses, giving us 340 undecillion, 340 trillion universes with a trillion networks in every universe, with a trillion devices on every network. Plenty of numbers. It's very difficult to run out of IPv6 addresses. We would have to really push the limits of human stupidity to do so. So I'm hoping that we are only going to go through this transition once. Fact is, it's been standardized since 1999. So we're now, coming up on year 13, 14, since we have an IPv6 protocol that people can deploy. The operating system vendors, your laptop builders, your server builders, all put v6 in their stacks. In 2002 and 2003, I couldn't find a vendor who didn't have an operating system software load that supported v6. Some of them weren't standard, some of them you had to work at, but the fact is, this isn't all that new. And in fact, even the router vendors got on board and made it part of their standard loads. So people have had the ability to deploy v6 easily for more than 10 years now, but they don't, or they haven't. It's a slow deployment problem. We'll talk a little bit about that, but the fact is that we built a wonderful protocol. We just left out any reason to deploy it. I wrote an RFC, RFC 1669, which said we don't really have a market solution for IPv6. We know we want it. We know everyone will want it at some point. But the deployment model is predicated on people realizing that years before the problem actually occurs. And that may not be good because something called NAT is coming. And NAT will get in the way of v6 deployment. This is in August of 1994. You can go look up RFC 1669. Fact is that that's what happened. We have a problem in that The incentive for when you want to deploy IPv6 really only appears for most people when they've run out of v4. And even at that point, because v6 isn't a good substitute for v4, things are problematic. So we have a bit of a challenge. We let the IETF build the marketing model, and the IETF is a bunch of engineers, and their marketing model is as good as you'd expect. So we have a challenge with v6 deployment. So what happened in the meantime? As Jeff said, while we were busy working towards this, we ran out. February 2011, that's the IANA giving out the last of the addresses. The guy who's off to the right because his belly's in the way, that's me. And we're all getting our last /8 address block. That last /8 address block is 16 million addresses. As we noted, some of the RIRs went through that very quickly. In a matter of weeks, APNIC had gone through the addresses they received in the final allocation. This is what it looks like historically as we run out of addresses. Now, the fact is there's the same number of IP addresses today as there is in 1978. We're not really running out. These aren't destroyed. They're not consumed by use. They're just allocated. They're out there. And in some cases, they're out there, but they're unused. They got allocated in the earliest days, and someone may not have been able to, at that time before CIDR, they may have gotten a very large address block and have no use for it. That's a little bit of the problem. But when you look at the run rate here, those are in /8 equivalents, and you can see in any given year, we went through a lot of them. Choose 08, that was probably a small one, 3 or 4 /8s. 09, you can see we went through 6 of them. 2010, well, we went through 22 of them in 2010. So even if you run out there and got a lot of the address space that's unused back into play, I have to tell you folks, it doesn't actually permanently move the needle. It's a delay of game at best. So in this aspect, people are right. We can use the addresses we have out there better. That's a big part of the transfer market discussion. But it may not actually change the problem. Long term, 4.3 billion is a very small number of addresses for a planet with 7 billion people, all of which want a mobile phone and a home connection and a computer at work. So it's just 4.3 billion is small. What do we have? Well, this morning we have 2.4 /8s in inventory, 2.45, which is about 40 million IP addresses. We are going through them rapidly. You can look every morning. It's updated on our website. I would suspect, I'm not one to argue with Jeff Houston, the prognosticator of IP address depletion. He says we're going to run out sometime in about a year, maybe next summer. That's good enough for me. I believe we're going to run out. It is true in the ARIN region, however, that things have slowed down, and he pointed that out. In the ARIN region, people have gotten a little more efficient with their usage of addresses. A lot of people have cleaned up their records, and so as a result, we're not seeing the draw going quite as quickly. We do have a countdown plan to make sure as we get towards runout, people are well informed. I want to talk about IPv4 requests. Pretty steady. These are requests for address space. The IPv4 assignments are in blue, light blue, and the IPv4 allocations are in dark blue. And they were steady throughout last year. So it's not like people aren't asking. They're still asking for addresses. If you look at actual space issued in terms of equivalents of space, so this is /24 equivalents, 256 addresses, you can see we do occasionally get a surge when a party comes in. Again, the light blue is assignments and the dark blue is allocations. So yeah, most of the space goes to ISPs, and occasionally when a large ISP comes in, a lot of space can go out the door. That's why forecasting this can be so hard. The top 20 or so ISPs, it's very hard to know when they'll come in and look for additional space, but when they do, it's because they've used the blocks allocated to them. So I say next summer, but if things suddenly surged, it could be a lot sooner. Not easy to predict. So we all know v6 is the answer. It's the one we have to get to. We are seeing growth in IPv6 in the region. So this is IPv6 allocations and assignments again, allocations in black and assignments to end users in light blue. And you can see they surged up to 2011. 2011 was the Runout event. We had a lot of press in 2011. It was globally, when the IANA ran out of its free pool, the central free pool, it was recognized globally there were 3,000 articles in the 2 weeks following the depletion event that we held at the ARIN meeting in Miami. That's a lot of press, and a lot of people requested addresses. And then it dropped off, which was surprising to all of us, but it dropped off. Requests for V6 peaked in 2011 because people knew about this, and everyone figured, oh, I better go get my V6 address. Don't want to get that before it runs out. Not that that was going to happen, but people were motivated to go get that V6 address. And so, but it faded over time. And in fact, if we go and look, IPv4 versus IPv6, in the region, we have about 4,400 members, or 43 ISP subscriber members. We have about 2,000, roughly, that we recognize as having IPv6. And that means a lot of them don't have IPv6. They haven't requested an IPv6 allocation. This graph's actually really interesting. So this is just the ISPs. And you can see the ones that are IPv4 only, and you can see the ones that are IPv4 and IPv6. IPv4 and IPv6 is in orange. And it's growing. But you actually can see the taper. It's growing and flattening. You know, right now, I guess Tony could do a best fit regression analysis and tell me, but I will tell you with my eye, that tells me we don't cross in the near future. We cross a lot further out than I thought, like 4 or 5 years. Whereas if you looked at the rate, these are quarters, if you looked at the rate going back a year and a half ago, you looked at the 2011 rate, you'd think by 2013 half of the ISPs had V6. No, it could be another 2 or 3 years. So we had excitement, and it's fading. That's a little problematic, and something we probably need to talk about. So there have been some things Internet Society should be commended for its efforts. Certainly, the Internet Society has done 2 major events, the World IPv6 Day and the World IPv6 Launch Day in 2011 and 12. One was a one-day trial where ISPs and websites turned on V6 to 24 hours, or maybe longer if they wanted. And then the other one was Launch, where they was turned on permanently. A very exciting event, and has definitely enabled IPv6 adoption, because you know that a very large number of organizations, 3,000 plus websites, including a significant percentage of the top websites, have turned on V6 for their content and left it on. That's awesome. But the reality is that being able to get to 20% or 30% or 40% of the content doesn't matter if you can't get to the other 50. And so IPv6 isn't a substitute yet for IPv4. So we tell people they need an IPv6 plan. I do a lot of talking about this. I've done, well, last year I did 50 some odd events and speaking engagements. This year I'll probably do a similar number. And sometimes it's amazing. We talk to people and we say this is going on, and people say, yeah, I know what's going on. I'm waiting for someone to tell me go. Okay? Well, I'm telling you, go. The problem we have is that it's very difficult to discern a business driver for IPv6. About 3 weeks ago in the Wall Street Journal, Deloitte Consulting had an article. I was the byline on the article. And it explained the fact that if you want something connected to the internet, at some point it has to be both V4 and V6, because the internet is both V4 and V6. Now the reality is that every ISP connects up every one of their customers and makes sure they have connectivity to V4 sites. You can't be an ISP and not provide IPv4 connectivity. So every website that's reachable via V4 thinks, I'm good enough. There's no one selling IPv6 only as a viable internet solution, okay? Not standalone. Now, that's really the problem. That's what we need to overcome, because at some point, people have to realize, yes, I need to have my website be bilingual. my content on the internet has to have both v4 and v6, because that unsung ISP, as people know, there's in some fields, there's things like tombs of the unknown soldier. We don't know who he was, but he gave it all for his country. The ISP who says, I'm connecting people up to the internet with v6 only, and I'm going to be in business a year from now, okay? That unsung hero will drive a lot of websites to connect their content up with v6. Mind you, that's a brave soul right now, because by bits, well, by websites, it may only be 10% of the websites are connected. Exact numbers depend on what you want to measure. Alexa, Alexa 1,000, Alexa 100. By bits, if you have a heavily consumer base and they spend all day on Facebook, it could be pretty good, but it's still only going to be 40 or 50% of that customer's bits. So we have this problem. You can't use v6 as a substitute for v4, and because no one's using v6 as a substitute for v4, content sites don't have to turn on v6. Very difficult situation. ARIN goes out there and tells people, you need to deploy v6 anyway, okay? If you're an ISP, you need to deploy it because at some point you're going to run out of v4. You may be able to go to the market for a while, but you're probably not going to be able to do that forever. So you need an answer. But for the consumers, for the content providers, it's a lot harder job to sell. We spend our time talking about it, but at the end of the day, we tell them, you need to have v6 connectivity for your content because we don't know when that first ISP is going to use v6 only. How do you get started? Dual stack your networks. It's actually not hard. The amazing part about this is it's technically easy. I went to a wireless ISP conference. There are thousands of wireless ISPs. I went to a wireless ISP conference. And these are the people who provide your connectivity when you're in a town square or a hotel or a coffee shop and you connect to the internet, you use their service. A lot of names you probably haven't heard, maybe some you have. You see them in airports. Very few of them are IPv6 enabled. And we had a discussion about this just a couple weeks ago, and one of them got up and said, oh, I turned it on. It wasn't hard. I turned it on for all my access points in all of my cities. I turned it on for our infrastructure. I turned it on for the web interception that we use to get the login and get your credit card, and it all works. It's not hard. It just took doing it. I had others in the room who stood up and said, no, we figured out it's a multi-year project that involves tens of thousands of dollars and consultants, and it's a nightmare, okay? That's the problem we have. The problem we have is that some people perceive this as a huge problem. It actually isn't. If you're a networking engineer, the concepts you have not changed significantly, v4 to v6. So, dual stack your networks. Make your servers reachable via both v4 and v6. If you have a website on the internet and it's not connected via v6, it's not fully on the internet. I don't know why you go through a lot of money to put an application on the internet and then not actually put it fully on the internet. But a lot of people do. If you're not a backbone, talk to your upstream about their IPv6 services. You want access to the entire internet. And you might get that from different providers. You might get it from the same provider. You might get it over one pipe. You might get it over two. Your choice. And a lot of transition technologies available. That's something I'm going to opt out of, but I'll just tell you, it seems that every time I turn around, there's 2 or 3 more transition technologies to look at because we didn't build this into the answer on day one. Okay, what can governments do? What else can you do? Audit your equipment. That's important. Know what doesn't support v6 so that when you buy something, you're not buying something that's going to be obsolete shortly. Encourage vendors to support v6. This is pretty important. I'm going to talk more about this, not in this slide deck, but at another time, maybe on the panel. But the fact of the matter is that we have to tell people to support v6, and that the best way for us to do that is as a customer. Nothing motivates someone more than saying, I'm not going to buy your service because I can't use it over IPv6. What can the government do? Well, actually, a lot of people say, when are they going to regulate this? When are they going to regulate IPv6 and mandate it? Never had ARIN members stand up and say, John, I want the government to regulate the internet. I have had them stand up and say, I want the government not to regulate the internet. But the other way around doesn't come very commonly. And in fact, our activities with government have been focused predominantly as government as a buyer of IT services. U.S. government spends $63 billion every year on IT services. It doesn't take diverting much of that to IPv6 to create a powerful motivation for people to deploy it. Same with Canada. The Canadian Minister of the Interior announced that they are going to turn on their websites with IPv6. U.S. government has an official declaration, and in fact, the irony now is if you go to NIST, to their IPv6 progress tracker, where they track websites that are v6 enabled, they track vendors, they track universities, and then they track government websites. As a percentage, the government websites are doing better than the commercial vendors and the universities. So the gauntlet's been thrown. The U.S. government is making progress in deploying IPv6 across its websites. Okay, and that's that slide. That was an official memorandum issued two years ago by the U.S. government, and it's making progress. Your checklist I kind of already hit: address space, connectivity, do an inventory, know what your tools and operating system software and tools are. Do your router, firewall, and other hardware upgrades. Make sure your vendors know you require support. Training, there's a number of great training resources online. Some of them are free. There's a number of great people out there who will do training. And get involved with ARIN. We manage the IP address space for the region. So if you're interested in how that gets managed and the policies that are used, there's a whole policy process and you can get involved. You can get involved in person. We also have open discussion, a lot of discussion, enormous amounts of discussion on a number of mailing lists that you can join, and you can actually participate in the development of these policies. A lot of references. ARIN, getipv6.info is our wiki, which is you can go upload presentations you've done, any lessons learned, deployment plans. The Internet Society Deploy 360 project is a wonderful resource. NANOG there's always presentations about v6. And then the folks at DREN, which is the US DoD research network, have a lot of IPv6 information in their knowledge base. That's it. That's all I have. Thank you for having me, and hopefully that's a good status of where we are with IPv4 depletion in the region. Questions? No? Yes?
When you guys get down to your last /8, are you going to start changing your policy?
The question is, when ARIN gets down to its last /8, will it start changing its policies? So we actually have a policy that requires us to, not policy, but an operational practice that states how we're going to process requests. And we will be more careful as we get towards the end to make sure that those last addresses are allocated to a party correctly and that it's been reviewed sufficiently. But the policies themselves don't change. Now, in the other regions, they have actually reserved address space in the final /8, their final /8 block, for particular policies, set aside so that any party can come and get one final sip of IP addresses. We have not adopted a policy like that in the ARIN region. It's been discussed. It's been felt it isn't needed. Owen?
We do actually have two policies, each of which is for /10, one for critical infrastructure and one for transitional technology.
Right. We have reserves that are not general purpose, which would apply for our transition technologies to get to v6 and also for our critical infrastructure pool. But for the average party coming in when we're below /8 that's looking for addresses, it's not as if we're setting aside them. We'll be going through that final /8 at the same rate as we do presently.
With the exception of those two towns.
With exception of the two reserves, right. Other questions? Yes?
When someone requests an IP6 address, are they going to turn in their IP4 addresses to you?
No, you do not have to turn in your IPv4 addresses to us. So the question is, when you get an IPv6 address, issued to you, do you need to turn in your IPv4 addresses? No. You can get an IPv6 prefix, and the IPv6 prefix, in the past, we would look up the fee you had to pay, ARIN, for the v4 and the fee you had to pay for the v6, and we'd have you pay the larger of the two, okay? This meant that, amongst other things, it got very interesting. A lot of times, because the categories for v6 were so large, getting v6 required paying more. We actually are changing the fee schedule. There's a pending fee schedule, which will take effect on July 1st. It's going to be discussed next week at our ARIN meeting. And it provides a category that allows a certain amount of v4 and a certain amount of v6. So for every size ISP, there's a matching v4 and v6 level. You can get up to that amount of v6 space. You maintain your v4 space. You don't pay any more. If you get more v6, like if you're extra small and you end up getting enough v6 space to make you small or large in our measurements, then you'd pay more. But effectively, every ISP can have a v4 and a v6 block. They pay one fee, and it covers a limit in both categories. Does that help? Okay. Yes?
How do you see the whole swath of internet modernization?
Internet modernization.
Which I characterize as broadband, wireless broadband, mobility,
Sure.
virtualization, cloud computing,
So,
and IPv6 and how that's impacting convergence with critical infrastructure.
so it's interesting. We have the question is, how does the rapid technology changes in the internet interact with the IPv6 deployment? And it's interesting. It's a very interesting problem. There are some cases where these technologies are going to actually drive v6 because they have no choice. So, for example, you just look at LoWPAN and sensor networks. All you need to do is start playing with 1 million sensors running somewhere, and you're going to be using IPv6. There's no choice. But in a lot of cases, the technologies that are going on, the people doing cloud computing, the people doing virtualization going on, the huge amount of activity going on with respect to content and virtual servers, are using v4 because they still only need one IP address to get that server online. And one IP address for a server is pretty easy. So the problem we have is that there are actually from some very large providers, for example, in the cloud industry, who didn't support IPv6 until last year. There's one that doesn't support it even now, so if you put your application up, you can't get a public IPv6 address, or you have to get it manually by going to their network operations center. So the people doing all the innovation are innovating, and the internet to them is a given. And this v4 and v6 is just infrastructure. It's a detail in deployment. I've been to a number of conferences in the Bay Area. I've been to conferences of sort of the next generation digital crowd, and they all talk about everything they're going to do over the web and everything that they're going to do over the internet and all the great changes coming. And I ask, I'm sorry, do you actually have enough numbers for that? And it's an unknown to them. It's a detail that gets handled in deployment. So I don't think, with the exception of the sensor community, I don't think any of that's actually going to drive v6, because the decision to consciously use a different protocol is an implementation decision made 4 layers down. Now, someone is going to make a decision to start rolling out services with v6 consciously, okay? And I know that will happen. You'll end up with someone who turns around and says, I'm going to deploy a cloud solution in a private environment. But if you're doing anything over the public internet right now, you still can't rely on the fact that your customer can access a v6 resource. So it's not yet reproducible. At the end of the day, some technologies are going to drive v6, like the sensor community, but the vast majority of it isn't a driving force. It's actually still trapped on v4, and it's going to remain trapped.
So I would say that FCC National Broadband Plan, Department of Commerce, NTIA FirstNet, and public safety, not a private sector.
Sure.
That growth is tied to mobility, and that will.
So there are a number of initiatives. So the FirstNet, which is the new FirstNet responder network in the United States, the work being done in Canada on their 911 rebuild. in the US, the work being done on smart power grid are all going to be private internet-based communities that will make use of V6. They may not have any impact for years, however, on ISPs actually deploying V6 solutions because they are closed community. And they can be done by one service provider in a private community. It's not a force felt by ISPs everywhere.
Locally, domestically, I'll say.
Yep.
Telecommunications is the second critical requirement for emergency management.
Right.
And that ties directly to public safety and FirstNet.
Right. And as I said, it could create some ripples, but it's not the type of thing. It's much like the U.S. government's requirement. In 2003, the U.S. government said, we'll only deploy equipment that is IPv6 capable. In 2008 and 9, they actually are required to verify IPv6 connectivity to another U.S. government agency over their ISPs. You would think this means every ISP serving the federal government would have to have V6 services. In 2010, 2 of the ISPs on the federal contract still didn't support IPv6. So the fact that it's mandated doesn't assure that it makes it into an ISP deployment plan. Okay, I can take one more question before I go over. Yes, Mr. Richard Jimerson.
John, you had mentioned the policy process, how the committee comes together and makes its policies. Do you have to be a member of ARIN to participate in that process? And if no, who can?
Anyone can participate in the process. You don't have to be a member of ARIN. So everyone can participate both in the online forums, and they can participate remotely when we have a meeting, and we actually do these with remote broadcast and remote participation, including asking questions and being counted in the show of support. The policy process is open to the entire community. It is not just the members. And so we'll talk a little bit about that when we talk about the policy process next. Excellent transition. Thank you, everyone.